In this video, I would like to introduce the simple linear regression. Simple linear regression is a fundamental machine learning technique used to model the relationship between a dependent variable and a single independent variable. It provides a straightforward way to understand and predict outcomes based on a linear relationship between the variables. Assumptions of simple linear regression. Number one is linearity. The relationship between the independent and dependent variable should be linear. The second one is normality. The residuals or errors should follow a normal distribution. Number three, homoscedasticity. The variance of the residual should be constant across all levels of the independent variable. Number four, independent. The observation should be independent of each other with no autocorrelation. Model equation and interpretation. The simple linear regression model is expressed as the equation y equal to beta 0 plus beta 1x plus e, where y is the dependent variable, x is the independent variable, beta 0 is the y-intercept, beta 1 is the slope, and e is the random error term. Interpreting the parameters, the slope b1 represents the average change in the dependent variable y for a 1 unit increase in the independent variable x. Holding all other factors constant, the intercept beta 0 represents the estimated value of y when x equals 0. The rule of residuals. The residuals, or the difference between the observed and predicted values of y, are used to assess the fit of the model and identify any patterns or outliers in the data. In this slide, I will teach you about estimation of model parameters. Number one, model specification. Define the simple linear regression model equation. Number two, least squares estimated. Estimate the model parameters using the method of least squares. Number three, interpreting the estimates. Understand the meaning and implication of the estimated parameters. The key step in simple linear regression is to estimate the model parameters, which represent the intercept and slope of the linear relationship between the predictors and response variables. This is typically done using the method of least squares, which provides estimates that minimize the sum of square residuals. The estimated parameters can then be interpreted to quantify the effect of the predictors on the response. Hypothesis testing in simple linear regression. Number one, test hypothesis. Formulate null and alternative hypotheses. Number two, calculate the test statistic. Compute the appropriate test statistic, for example, t-test. And number three, determine p-value. Number four, compare the significance level. Number five, draw a conclusion. Here I will show you the coefficient of determination, or R-square. The coefficient of determination, denoted as R-square, is a statistical measure that represents the proportion of the variance in the independent variable that is explained by the independent variables in a simple linear regression model. R-square range from 0 to 1, with 0 indicating that the model explains none of the variability in the response data around its means, and one indicating that the model explains all the variability. For example, r square equal to 0.72, typically value for a good model. R square equal to 1 indicates that a perfect fits of the model to the data. If r square equal to 0 indicates the model does not explain any variability in the data. This part is also very important. What is that? A residual analysis. There are three parts. Number one is understanding residuals. Residuals are the difference between the observed values and the predicted values from the regression model. Analyzing residual is crucial to assess the model fit and identify any variation of the underlying assumptions. Residual plots. Plotting the residuals against the predicted value or the independent variable can reveal patterns, heteroscedasticity, or outliers, helping to identify potential issues with the model. Normality of residuals. Checking the normality of residuals is important to ensure the validity of hypothesis testing and confidence interval calculations. Residuals should follow a normal distribution too. Prediction and inference. Number one point, prediction. Simple linear regression allows us to predict the value of the dependent variable for a given value of the independent variable. Number two, confidence intervals. We can construct confidence intervals for the predicted values to quantify the uncertainty in the predictions. Number three, hypothesis testing. The model can be used to test hypotheses about the relationship between the variable, such as the significance of the slope coefficient. Number four, forecasting or predicting. The model can be used to forecast the future values of the independent variable based on new observation of the independent variable. In this slide, I will show you the limitations of simple linear regression. Number one, linearity assumption. Simple linear regression assumes a linear relationship between the predictors and response variables. This may not always be the case, as real-world data can exhibit more complex, non-linear pattern. Number two, single predictors. Simple linear regression considers only one predictor's variable. In many cases, multiple factors may influence the response, requiring the use of more advanced techniques like multiple linear regression. So finally, I will talk to you about what is the conclusion and key word or takeaway in simple linear regression. Number one, summary. Simple linear regression is a powerful yet straightforward technique for modeling the linear relationship between a dependent variable and a single independent variable. Key takeaways. Understand the key assumption, interpret model parameters, assess goodness of fit, and use regression for prediction and inference. Apply judicially, considering limitation. And last one, next step. Continue learning about more advanced regression techniques like multiple linear regression, logistic regression, and nonlinear regression to expand your data modeling toolkit. So thank you for watching and thank you for attending my class, and see you in the next week. Thank you. Bye-bye.